Hi everyone, today we're gonna take some parts out some old PCBs that I got lying around. I'm just gonna show you some of the PCBs. So what we've got here is an old PCI graphic card for computer. What you got on it is shunt voltage references. You got these are TL431s. So you got 1, 2, 3 over here. You got some buffers, some 74 logic, which I'm not interested in. You got some diodes here and some transistors. I'm not interested in those either. You can take the memories out, but not really no point. So the most important thing I'm going to take out is the voltage references, and this voltage regulator. So I'm going to take out of that. I might take the heatsink. I'm not sure about that. I might remove the heatsink. See what's underneath on the side of the chip that the heatsink stuck on. So that's one. There's another one that I've took out. Actually, there's not much, as you can see here. So again, I've got 1, 2, 3 voltage references here. I've got crystal oscillator if I want to take out. Again, I've got the same kind of discrete components here. I've got the capacitors and I've got transistors. I've got another tantalum capacitors, which is not, I'm not going to bother taking it because I've got plenty of them. So what I'm interested is these voltage references and this voltage regulator. What other stuff I have? I've got these daughter board processor boards, which I took out of old G4 Apple computers. Now what I got here is really cool that I've got inductor here. I got bank of capacitors, tantalum capacitors. I got more here, I got more there, and I got a few over here, which I will take out. I will show you how to take these out without damaging these. I've got DC-DC converter here. I've got DC-DC converter. I've got some MOSFETs, and I've got a voltage regulator here that I will definitely take out. You can take out the memory if you want to. These are Samsung memories. They're used for the level 2 cache of the processor, but I'm not going to bother. Again, I'm going to take the MOSFETs. These two MOSFETs I'm going to take out. I will take out these large power SMD resistor, and yeah, so that's what I'm going to do. I'm going to take these capacitors, the MOSFET, the DC-DC converter, and the voltage regulator. Again, I've got another one of them. You can see here I've got tons of bank of tantalum capacitors. I've got a MOSFET. I've got another surface mount capacitors. These are I think ceramic layers capacitors. I've got a MOSFET here. We've got a few other capacitors if you want to take out. I've got the MOSFET here. Again, DC-DC converter here. What's interesting here, I've got a Xilinx CPLD here. You can see you can take this out because the good thing about these CPLDs is that their programming is usually installed or burned onto EEPROMs. You can't burn the programming on the actual CPLD itself. I think there are a few that you can do, but this one I've looked on Google, and it does require external EEPROM. So this is the EEPROM. This is the Atmel EEPROM. So I will take this out. This is an old, this discontinued. They don't make this CPLD brand, this part anymore. But hey, for testing and doing some random work is fine. Again, I've got the same ceramic capacitors here. You can, as I said, you can take the memory out if you want to, but I'm not going to bother. And I've got an inductor here. So we got the same thing again here. And again, I've got another graphic card with shunt voltage references on them, which I will take out. This is another thing. Every part that you have, everything that you have, you can salvage parts from at home. So this is an old school CD-ROM board that I had. I think this was from an old DVD-ROM for old Apple G4 Power Mac. And what I've done, I've just taken everything out. I just kept this board. And what you got here on the board, again, I've got some voltage references and transistors here. I've got the motor drivers. So I got one motor driver here. I got another one, and I got another one. I will take these out because sometimes when you got CD-ROM or DVD-ROM at home, this are the most important thing that most of the time they fail. As you can see, they do require kind of a heatsink or some sort of coupling to the case. Usually there's a heat transfer, like a tape or little gluey kind of thing stuck on top of this, and then that helps the heat transfer from this to the case of the CD-ROM or DVD-ROM. So what I'm going to do, I'm going to take these out. I'm not going to bother with the rest of the stuff, you know. Most of these ICs and stuff like that are just built for this kind of purpose, so I'm not going to be using them for anything else. So yeah, what I'm going to take these out, and I'm going to take the voltage regulator and the transistors out. On the other side, you got some capacitors, which I'm not going to be bothered with, and yeah, that's it. I'm not going to bother with anything else. There's some memory and some other bits and bobs in there, so I'm not going to bother with them. Got here, we got the motherboard for the we got the motherboard for the actual Mac. So what we got here, what I'm going to do is I'm going to take the transistor out, I'm going to take the op amp out. I'm not going to be bothered with anything else. I'm going to take this crystal oscillator out. I'm going to take the inductors out, and what I got here, we got a voltage regulator, which I will definitely take out. I got inductor here, and we got a DC-DC converter, which I will take out. Again, here on this side, the camera focuses. Yep, we got some MOSFETs here. I will definitely take out. I will take the power transistors and flip it over. Yeah, we got to get some discrete and some other bits and bobs here. I will take out these ICs. These are the LM339 and the LM343 or some things like that. I will take out, and again the transistor, diode, and some more op amp down here I will definitely take out. So I got 3 of these boards, and we got here. These 2 are the same, but this board is different. As you can see here, it's got much more components on this side. So I've got one voltage regulator here, I've got another voltage regulator here, and I've got another voltage regulator here. So I definitely will take these out. I've got inductor I will take out, and some Farad bead and some oscillator that I will take out as well. And this is the back of it. There we are. One thing with these, I might take some of these resistors out. You can see here these resistors. Good thing to tell that these are you know, high. These are oh, I forgot the name for them now. The tolerances. These are high tolerance resistors. So basically means that you know, whatever the value they are, these are kind of expensive resistors. As you can see by the color are different. You can see here these are light blue compared to the normal black colored resistors. You can see here, so these are obviously more expensive than the other ones. So I might take some of them out. You can see here, you got these ones which are blue. So I might take some of these out, but I got quite a few of them anyway hanging around on my part. So I might just take out some of them just in case. As you can see here, again these are all blue. You got the black one here and you got the blue one here. So these blue ones are obviously more expensive than the black one because these are better tolerances they got compared to the normal ones. So this probably be 0.1% compared to, like, you know, maybe 1% or 2% tolerance on these ones. So yeah, I usually take these ones out which got different colors. So yeah, we're gonna go start dig into it. So what you need for taking surface mount components out. Okay, so on my bench here, I've got this plastic ESD mat that you can see here, but it is heat resistance. You know, you can put these here and straight go with your heat gun to take it, but I won't do that because after a while it just gets a bit funny and start having bubbles coming out of it and stuff like that. So what I've got to do, I've got to use just the normal book that I've just used for taking parts out. I put this on the board, on the book, and then with a tweezer and with my heat gun, I'll just heat it up and take it out. And the heat gun that I have is one of those cheap ones that you can buy. It's the A10 85-8D, which I think I bought it for about £30 delivered from eBay. It's got a few different nozzles that comes with it, but usually when I do work I take the nozzles out because you get more of a heat spread. The heat is not concentrated in one place. so that way I can, like, you know, I can quickly just heat a whole area out and then quickly just take the ICs out, you know, without damaging them too much. This way, it's just, if you want to work in one place, then that's what you got to do. But usually I just put this, just take it out. What I do here, I got a temperature at about 280. So I'll just quickly show you how I go about doing this. The good thing is you need to just move this around. It's just, you shouldn't really just focus in one place, because you don't want the IC to, you know, to get too hot and damage the IC. So it's just like a circular motion, just, you know, move it around till you get the board to temperature. It takes about, I think about 10-15 seconds for the heat gun to reach the temperature that you've set it to. These D-pack chips, transistors, are a bit hard to get up, because the actual backside of the actual transistor is soldered straight to the board, so it takes a bit longer for it to heat up and to get released from the board. But don't be scared, you won't damage it. It will take a bit of time, but you won't damage it. It's a bit hard to do this because I'm constantly checking on the camera as well. There we go. Nope, doesn't like to zoom to it for some reason. Anyway, that's one of the ICs out there. So what we're going to do is go quickly remove the rest. Yeah. The reason it takes a bit long is because these boards, they got a big ground plane on them. So obviously the copper inside sucks all the heat from the heat gun. So it takes a bit longer for it to heat up. But yeah, as I said, don't be scared. It takes a lot to damage these chips with you know, with heat. So that's one done. As I said, I'm not going to bother with the rest of the stuff. So that's one board done. Chuck in the bin. Move to another one. So I'm gonna bring the camera a little bit further down so you can actually see what I'm doing. So we got here. I gotta do this without the camera trying to commit suicide again, like many times that I've done. There we go. So we got the IC here, and we got one there and another one there, and again we got the voltage regulator over there. Okay, so that's one done. What we're going to do later on, we're going to test these randomly and make sure that, you know, they're working order, they're fine, and we haven't damaged them. There we go. Another one. Just bring this down. Let's see what we have taken out so far. Just from some old crappy graphic card. So far we got 5 voltage references and 1 voltage regulator. There we go, that's fine. You don't need anything else from this board either. Chuck it away. Move to another one. What you got here, I don't know if it's clear on the camera. We got a resettable fuse. Usually I take them out. I just noticed that this got a resettable fuse on it. Let me just take the other ones, see if the other ones got them as well. Yep. Yeah, and the other one's got some ferrite bead that I will take out. So we're gonna go through those boards again. The reason I take these reusable, resettable fuses out, I'll just show you, let me just finish this, is because most of the time, if you got computer or any equipment that uses, it's got USB on it and stuff like that, most of the time it can be this fuse that is damaged and it's not powering, providing power to your device, or it's, your USB is malfunctioning, it's not working properly. So it's good to have some of these lying around in your lab. So right now what I'm doing, I'm just heating the fuse out. You got to be careful with these fuses because they're just layers of some conductive material, so you don't want to heat them up too much, and you got to be careful when you take them, pick them up. So there we are. If the camera focuses, no, it doesn't like to focus for some reason. There we go. So that's one. Fuse out. That's done. On this one we got some ferrite bead here as well. We got 2, oh, not in the camera. We got 2 ferrite beads down here that I'm going to take out, and we got the resettable fuse on top down here, which we will take out as well. With the ferrite bead you don't have to worry about the heat and stuff like that, because there's not much that can damage them, there's nothing in them. Obviously just the ferrite bead. So there we go, that's one. And that's another. And then we're going to move into fuse. There we go. So that's done. Don't need that anymore. So here's the fuse here, and again we got some ferrite beads there. Can take those out. One thing you got to do is you got to just have patience. There's no point of forcing the part out, because as I said, these you can easily damage these fuses, because once they get hot, the material in them is obviously hot as well. So if you you're trying to pull it and push it and trying to force it out, then you might damage it without you noticing it. And then once you use it in your equipment, and you gotta have all kind of problems. So it's good to be patient. Just take your time. So what we got here, let's focus. So let's just take these MOSFET and the power resistor out. One thing with this board is very heavy, and it's got a really thick copper ground on it. So you gotta give it more heat, and you gotta, as I say, you gotta be patient. It will take a bit of time to heat this up, especially as you can see here. You got a big, massive ground plane, and you got a ground plane in the middle of this. This is obviously 4 or 5 layer board, maybe more. So it does have a couple layers in there. So it's gonna take time. It's gonna take a while for it to warm up. So just be patient, and you will get the part out. With the resistors, you can just focus on one point and heat them up, but you don't want to heat them up too much. Again, Just because they're resisted doesn't mean that, you know, they're not going to get damaged. Here we are. There we go. So that side is done. Now what we've got here with these tantalum capacitors, you shouldn't really focus in one place. So if you want to take the tantalum out, don't put your heat right straight on top of them, just put them on the side to side. There we go here. There we are. It's one tantalum out. There's another one out. And another one out. You can take these ceramic ones out if you want as well. Or we hit them up, so we're just going to take them out as well, why not? We've got some diode, discrete diode here. There we go, we got the MOSFET again. We've got the DC-DC IC. Yeah. See how easy it is to just remove parts. The inductor, I'm going to use my soldering iron to take it out because it's much easier. It's good to have good ventilation while you're doing this because you get all kind of, you know, fumes coming out. You don't really want to, you know, start doing this for hours and just, you know, taking all that fumes in, because if you know, obviously these fumes are not good for your health. So it's good, you know, as long as you got window open or some form of, you know, air coming into your room or wherever you are, you should be fine. Shouldn't worry about it. But it's a good idea always to pay attention to health and safety, because it's there for your own, you know, for your own good. You know, it's a good idea maybe you wear protective glasses, because sometimes I have, you know, I've been using the hot air and trying to take things out, and things have exploded. So you know, it's a good idea to have protective eyewear. So yeah, I'm not going to go through all the boards and show you, you know how I do it, or it's going to take forever to take those out. Just as you can see here, let me just put the gun away. Yeah, as you can see here, that didn't take long. And what we got here, we got some ceramic capacitors, we got resettable fuses, we got ferrite beads, we got voltage regulator. What we got here, we got tantalum capacitors. These are still might be hot, so I'm just gonna touch them with my hand. We got a DC-DC converter IC. We got a diode, again more ferrite beads. We got some resistor. We got some ceramic capacitors, again tantalum. And what we got here, we got our voltage reference, and we got our MOSFETs here. So you know, with few boards, just taking parts out, it does add up. After a while, we've got so much part, and if you got a part, if you got like so much of one part, there's no point of you wasting your time and trying to get every single part out. I mean, like, I got tons of ceramic capacitors. I really didn't need to take these out, but I just took it out just to show you that how easy it is just to, like, you know, salvage parts and take parts out. So what we're gonna do here, just to quickly show, see if these capacitors see, 330, if the camera zoom, there we got 330 microfarad tantalum capacitors. What we got here, we got a voltage regulator and a whole lot of other stuff. So yeah, it does pay to salvage parts. Not only it improves your soldering and hotair skills, it can be rewarding as well. Obviously you can get, you know, tons and tons of parts out and use it in your next project. So we got here, I got all of those boards to take out, and I got some boards over there to take out. So yeah, I hope you like this video about using hotair and taking, you know, parts out of old PCBs and stuff like that. As always, if you like the video, please give it a thumbs up, and until next video, thanks for watching and goodbye.